Hello everybody and welcome to our second lesson in Unit 2 on formulas and constructions. Today's objective will be we will be able to apply the distance formula to find the length of a line segment when given the coordinates of the endpoints. Now, what is the length of a segment? The length of a segment is the measurement of the distance between 2 points. And what is the distance between 2 points? It's the length. We can also say the absolute value of the difference of the coordinates of A and B. So length and distance are kind of like the same concept. Length is like distance and distance is like length. So if I get my handy dandy ruler and I measure this segment, I will find out that the length of this segment is 60 units, whatever those units might be, right? And I could also then say the length of AB is equal to 60 units. Measuring the difference, or rather the distance between these 2 points, let's assume that A doesn't start at 0 and doesn't have the coordinate 0. For example, A is at 20. So if A is at 20, then I see B is at 80. Then let's calculate our distance. The distance between A and B is the difference between the two coordinates and the absolute value of that. So we say 80 minus 20, the absolute value of 80 minus 20 is the absolute value of 60, which we don't need the absolute value bars for to know that it's 60. But even if we had calculated the other way around, the absolute value of 20 minus 80, this time we get negative 60, and this time we definitely need the absolute value bars to tell us that the distance between A and B is 60 units, and both ways we come up with the same result. So now stop the video for a second and think about and write down in the side margin of your note page, when in your everyday life do you need to calculate distances? Now let's go back and recall the Pythagorean theorem, which is a very useful thing that we use for finding the lengths of the sides of a right triangle. the formula goes c squared is equal to a squared plus b squared. Now, let's look at our right triangle. The side that's called c is called the hypotenuse. And if you see that little box in the bottom left, that's a right angle, and that right angle points directly towards the hypotenuse. The hypotenuse always has to be the side which is opposite of the right angle. The sides A and B also have a name. They're called legs. And it doesn't really matter which one is leg A or leg B. You can interchange those numbers, but C always has to be the hypotenuse. Now let's go and talk about finding the length, in other words, the distance in the coordinate plane. Find the length of the segment with these endpoints, P with the coordinates 0 and 2, and R with the coordinates -4 and 5. Write down another way you could ask this question. Pause the video and write that down in the line given. Maybe you also wrote down, find the distance between points P and R. Remember, the length and the distance is pretty much the same thing. Well, then let's use our coordinate plane and put the points down so we can actually try and find the length of the segment or the distance between those 2 points. I see that I have some x-coordinates that are negative. The y-coordinates are all positive, so I'm going to put my coordinate plane down something like this. The y-axis a little bit more to the right, and the x-axis more towards the bottom. And then our points, P and R. P is right here, and R is at -4, +5. And this is the segment that we would like to know the length of. But as you know, on a coordinate plane, we cannot count the boxes going diagonally like this. We can only count going up and down or going to the left and right. But why don't we try doing that right now? How many boxes is R above P? We go down this way and we see that it's 3 boxes above. And how many boxes is P to the right of R? Going like this, we see that it's 4. And guess what? We have just created a right triangle. And for right triangles like this, knowing the length of both legs, we can use our Pythagorean theorem to figure out the length of the hypotenuse. C squared is equal to 4 squared plus 3 squared. In other words, C squared is equal to 16 plus 9. C squared is equal to 25. Now we need to take the square root of that on both sides of the equation, right? And that will give us the answer that the segment PR has a length of 5. Well done, guys. For the same purpose, and in those cases where it's hard to put something down in a coordinate plane and count, we can also use the distance formula. And the distance formula is really based off the Pythagorean theorem. C squared is equal to A squared plus B squared. But we're going to start off by taking the square root of both sides in order to get rid of the squared sign for our C, which would make this formula look like this. C is equal to the square root of something. If we look over to the left to our coordinate plane, we see that we used a for the distance along the x-axis and squared it. So that's the x distance squared plus, and b was the distance along the y-axis squared. And how can we get the distance along the x-axis for 2 points? We just go ahead and we take the two x coordinates and subtract them from each other, right? And the same is also true for our y coordinates. And with all this being said, we can now write down our distance formula the way it is written, and then also apply it to the example given. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. This is another formula that's super important for you guys to remember, so please mark that one well in any possible way, and also make sure that you memorize it. Let's use our distance formula to find out if we get the same example for the length of the segment PR. PR is equal to the square root of, and now I'm going to go and look at my coordinates. I got x1 right here, which is 0, and x2 right here, which is -4. In other words, -4 minus 0 to the power of 2 plus, and now I'm going to look at my y coordinates. y1 is equal to 2, and y2 is equal to 5. So I got 5 minus 2 to the power of 2. Let's go ahead and solve it and see what we get. This is equal to the square root of -4 squared plus 3 squared, which is equal to 16. Remember, -4 times -4 is positive 16 plus 9. This is the same as the square root of 25. And so the square root of 25, as we already found out before, is 5. So the length of our segment PR is +5. This is the same answer that we got when we did it on our coordinate plane. This is what we wanted. Excellent work, guys. Now go ahead and watch the second part of this tutorial.